All right, picture this. A storm hits, the waters are rising, and the power's out. It's chaos. You reach for your phone, your one connection to the outside world, and you see it. No bars, no Wi-Fi, absolutely nothing. In that one moment when you need it most, your digital lifeline is completely dead. And look, this isn't some made-up disaster movie plot. This is the reality for first responders in places like Sri Lanka during monsoon season. This quote right here, it just hits you, right? All this incredible technology we have, our sophisticated smartphones become functionally mute the second things get really serious. So yeah, that's the million-dollar question, isn't it? When the entire infrastructure we depend on just vanishes, how in the world do you build a connection from scratch using only the stuff we have in our pockets? Okay, let's dive into this. To even start to figure out a solution, we first have to understand why this happens. It's not just one thing going wrong, it's a whole chain reaction, this cascade of failures that leads to total, complete silence. So what happens is, first, the main power grid often gets shut down for safety. Then the cell towers themselves might get physically damaged, blown over or hit by landslide. Even if they're standing, their battery backups only last so long. And here's the kicker. Even if the tower has power, the special links that connect it to the internet can get severed. The whole system is just way more fragile than we think. Your first thought might be, hey, there's gotta be an app for that, right? And you're right. There are tons of walkie-talkie apps out there. The problem is, almost every single one of them has a fatal flaw when you're in a real disaster. Let's take a look at why.
So you've got Zello, which is super popular with volunteer rescue groups. It's great, but it needs the internet. It works by sending your voice to a central server somewhere out there, which then sends it to your friends. And right there, that's the fundamental problem. If the internet is down, Zello is down. It relies on the very thing that's already broken.
Okay, so what about a true offline app like Bridgefy? It's kind of famous for creating these pop-up networks, but it's built on Bluetooth. And Bluetooth, it's designed for low power, small bits of data like from your headphones. It's fantastic for texting, but it is way, way too slow for clear, real-time voice communication.
And this brings us to another huge issue, even with apps that use Wi-Fi. See, a lot of them create what's called a start network. One phone acts as the central hub, and everyone else connects directly to it. The problem? You can't chain them together. If you're not in direct range of that one hub phone, you're out of luck. That single-hop design just doesn't cut it in a big disaster zone.
So after looking at everything that doesn't work, a team of engineers decided to build something from the ground up, designed specifically for that worst-case scenario. It's called LankaMesh Voice. The whole idea is just beautifully simple. The app literally turns a bunch of isolated, useless smartphones into one big private walkie-talkie network. No towers, no routers, no internet needed. It just creates its own network right there on the fly. And the magic behind this is something called a mesh network. The best way to think about it is like a digital bucket brigade. Instead of everyone running to one central well, you just pass the bucket to your nearest neighbor. They pass it to their neighbor, and so on. Well, here, the bucket is your voice message, and it just hops from phone to phone until it gets where it needs to go.
So how does this magic actually work under the hood?
Well, it's not really magic. It's actually a combination of 3 really clever ideas all working together to make real-time voice possible when it should be impossible. Okay, so here are the 3 pillars. First, it's a true mesh, meaning any phone can connect to any other phone. Second, it uses some seriously efficient audio compression to shrink your voice down to a tiny size. And third, it has a really smart way of passing that message through the network so it doesn't cause a traffic jam. Let's start with the audio problem. The raw, uncompressed sound from your phone's microphone, it's huge. We're talking about 768 kilobits per second. Trying to shove that much data through a makeshift Wi-Fi network with dozens of phones? Forget it. It would just instantly grind to a halt. But LankaMesh uses this thing called the Opus codec. It's the same tech used in professional systems. And here's where it gets kind of nuts. It takes that massive 768 kilobit stream and shrinks it down to just 16 kilobits. That's a reduction of almost 98%. Now it's small enough and light enough to just fly across the mesh network. So how does the message know where to go? It uses this clever flood protocol. When you talk, your message gets a unique ID. Your phone blasts it out to all its neighbors. They hear it, and then they blast it out to their neighbors. But here's the really smart part. If a phone gets a message with an ID it's already seen, it just ignores it. That stops any endless echoes. And to keep things tidy, the message is designed to just die after 3 hops so it doesn't accidentally swamp the whole network.
Okay, so the tech is brilliant, but it's totally useless if no one actually has the app, right? So how do you get this tool into the hands of people who desperately need it when they're smack in the middle of a crisis? Well, that brings us to the whole deployment strategy.
I mean, this is the ultimate chicken and egg problem. You've built the perfect offline communication app, but it's sitting on an app store that nobody can reach because there's no internet. So how on earth do you solve that? Well, the solution is just as clever as the network itself. The app can share itself. So if I have the app, I can just tap a button, and it will find your phone nearby and beam the installation file directly to you using Bluetooth. It's amazing. It means a single copy of the app can spread like wildfire through a rescue center, building the network one person at a time. And the whole field strategy is just as thoughtful. There's a beacon mode that uses low-energy Bluetooth to just listen, saving precious battery life. There's even a network energy meter that tells you if your phone is doing a lot of the heavy lifting and draining your battery too fast. And the big idea is that official rescue vehicles could become powerful supernodes, bridging the network and maybe even connecting it to a satellite phone. So really, when you boil it all down, what this whole project shows us is a pretty profound idea. In our race to build bigger, faster, centralized networks, maybe we've overlooked the incredible power that's already sitting in the devices we carry every single day. The solution isn't always about building more stuff. Sometimes it's just about smarter software.
And that kind of makes you wonder, doesn't it? If our phones can become a self-healing communications grid just like that, what else can they do? What other unbelievable, life-saving tools are just hiding in our pockets, waiting for the right piece of code to unlock them?